For modern-day technological navigational tools, animals and early generation Homo sapiens used visual and spatial cues for direction. Visual place learning in Drosophila Melanogaster, an experimental article written by Tyler Osford, Charles Zucker and Mitchell Riaza in 2011, discovered and reported on how common fruit fly can perform visual place learning techniques. The exploit bodies of the fly's brain, in particular the mushroom bodies, were studied by silencing to record the effects of visual learning. As the mushroom bodies were used for sensory processing, by silencing them it caused dramatic impairment, meaning the fly couldn't successfully create memory. This clarifies that neurons for the esploid memory are necessary for visual place learning of the fruit fly. A thermal arena was developed explicitly to test how the esploid bodies react in respect to visual place learning. The arena was designed likewise to the inspirational Morris water maze and the heat maze, as it was previously used for study of cockroaches and crickets. The objective of the maze was for flies to find a safe target of a cool tire amongst an array of warm ones and to restore this information for later. A thermal plate was designed with 64 1-inch squares arranged into an 8x8 grid. This design formed a base foundation for the thermal test arena. To disguise the tiled base, a layer of masking tape was used to make the arena appear featureless. The structured walls were of 8 inches in diameter and 3 millimeters in height. The visual cues provided were an array of LED lights, which formed a 3-part visual cue for the flies. These sections consisted of horizontal, vertical, and diagonal planes. The graphs here are proven evidence of the results recorded throughout the tests for the fruit fly. In figure 1 here you can see that 4 subjects were documented. These included the path, the time, the index direction, and the speed. The colours represented red for coupled, silver uncoupled, and black for dark. By looking at the graphs, it is evident that the flies in the coupled environments performed more efficiently than those in the uncoupled or dark environments. This proves that for spatial memory to work efficiently, the flies rely on lights such as visual lights for visual cues and the tile as a physical cue in temperature variance. In the second graph here, you can it further indicates that the coupled cues for the flies show an increasingly improvement compared to the tests performed uncoupled or in dark environments. At the conclusion of the thermal test trial, the flies undertook a secondary study. This study included the time frame of which visual and spatial memories could clearly be restored in the fly's brain. The test proved that the flies could retain visual memory for up to 2 hours. Visual inputs of the mushroom body of the whirling beetle, published in 2012, conducted further studies of the use of the mushroom bodies of the brain. The article was written by Chin Ling and Nicholas Stroh. Overall, the tests proved that the flies were a relevant subject as they were capable of recalling spatial memories in a complex environment.